All right, let's jump right in. Have you ever wondered what's really going on when the moon seems to just cover up the sun? Well, today we're diving deep into that incredible cosmic event, the solar eclipse.
So you can read about the science all day long, but the experience, that's something else entirely. Just imagine, it's the middle of the day, but the sky starts to get dark, the air gets cooler, and then you see this. The sun's magnificent, fiery outer atmosphere, the corona. It's usually totally invisible, completely hidden by the sun's own glare. Seeing it with your own eyes is just breathtaking.
So how does this incredible magic trick actually happen? Well, it all comes down to a perfect alignment, a straight line in space. Let's get into the mechanics behind this amazing sight.
To really get this, I'm going to give you a fantastic word for your vocabulary: syzygy. It sounds super complicated, right? But it just means that three or more celestial bodies are lined up in a roughly straight line. And a solar eclipse, it's the perfect example of syzygy, with the sun, the moon, and the Earth all falling into place.
And this diagram shows you exactly what's going on. A solar eclipse happens when the moon's orbit takes it directly between the sun and us here on Earth. When that happens, it casts this long shadow onto our planet, blocking the sun's light from reaching certain spots. But here's a cool detail. The moon's shadow isn't just one big blob. It actually has two parts. You've got the umbra, that's the dark inner cone of the shadow. If you're lucky enough to be standing there, congratulations, you're seeing a total eclipse. But if you're in the lighter, fuzzier outer shadow, the penumbra, you'll see a partial eclipse instead.
So where you are in that shadow makes a huge difference. But you know, it's not the only thing that decides what kind of show you're going to get. Let's see what else goes into making these different kinds of eclipses.
Okay, so this table lays it all out for us. You've got your total eclipse, that's the big one, where the sun is completely blocked because you're in that dark umbral shadow. Then there's the partial eclipse, where it looks like a bite has been taken out of the sun because you're in the penumbra. But then you have this other one, the annular eclipse. This happens when the moon is a little farther away from us in its orbit, so it looks smaller in the sky. It can't quite cover the whole sun, leaving this incredible fiery circle, the ring of fire.
You know, here's a really simple way to picture it. It's like holding your hand up to block the sun on a bright day. For an annular eclipse, it's as if your hand is just a little too small or a bit too far away to block out the whole thing. It's the same principle, just on a cosmic scale.
And, you know, for you die-hard astronomy fans out there, there's actually a super rare fourth type, a hybrid eclipse. This is wild. Because the Earth is curved, as the moon's shadow races across the surface, the distance actually changes. So an eclipse can start as an annular one, then morph into a total eclipse, and then go back to being annular again. It's the rarest of them all.
So this brings up a really big question. I mean, the moon circles the Earth every month. We get a new moon every month. So why don't we get a solar eclipse every single month? What's the deal?
I mean, that's really the heart of it, right? The moon goes around us about every 29.5 days. An eclipse can only happen during the new moon phase. So why isn't this a monthly thing? What's the catch?
And boom, here's the answer. It's all about a tilt. See, the moon's orbit around the Earth isn't perfectly flat. It's not on the same plane as the Earth's orbit around the sun. It's tilted, just slightly.
And it all comes down to this one little number, 5 degrees. Because of this 5-degree tilt, most of the time, when we have a new moon, its shadow just misses us. It passes either above the Earth or below it. It's only on those rare occasions when everything lines up perfectly on that flat plane that, bam, we get an eclipse. That tilt is what makes them so special.
But even with that tricky tilt, the universe has a rhythm. It's called the Saros cycle. It's this incredible pattern where every 18 years, 11 days, and 8 hours, the sun, the Earth, and the moon all return to almost the exact same positions relative to each other. It's like the universe has this built-in alarm clock, and it's what lets scientists predict when and where eclipses will happen for centuries to come.
All right, so we've covered the science, the why and the how. Now let's talk about what it's actually like to see one. If you're lucky enough to find yourself in the path of a total solar eclipse, what should you be looking for? So if you're watching, here's the play-by-play. It starts with first contact. That's when the moon just starts to take a little bite out of the sun. Then comes the big moment, second contact. The sun is completely covered, and totality begins. Totality itself is that magical, all-too-brief period where you can see the corona. Third contact is when the sun starts peeking out from behind the moon again, and totality is over. And finally, fourth contact means the show's over. The moon has moved on.
So just how rare are these things? Well, a partial eclipse actually happens somewhere on Earth at least twice a year. But a total eclipse? That only happens about once every 18 months, and you have to be in just the right spot on the planet to see it. And that moment of totality, it's so fleeting. At its absolute longest, it's over in about 7.5 minutes.
And all of this really makes you wonder, right? These events are beautiful, they're rare, they're over in a flash. What can these brief moments of daytime darkness really teach us about our own sun and our tiny place in this huge cosmos? It is truly a spectacle everyone should try to witness in their lifetime. But if you do, there's one more thing you absolutely have to know.
Okay, and before we wrap up, I have to leave you with the single most important piece of advice. Seriously, please take this to heart. Never, ever look directly at the sun, not even for a second. It will permanently damage your eyes. The only time it's safe is during the few brief moments of full totality. Otherwise, you must use certified eclipse glasses or other safe viewing methods. Your eyesight is priceless. So please, stay safe and by all means, keep looking up.